have to use a product rule because it wasn't a product. The second one, we had to use the product rule. And then the third one, you're correct, we got to use the quotient rule. And so here's my hint. Put both the top and the bottom in parentheses, and I expect to see, as you go through the process, these to be in parentheses as you go, okay? So what do I mean by that? Well, let's do the derivative. Now remember, you're only going to have to do the step that I show you next. You don't have to try to simplify it at this time. Okay, so let's look at number 3. So the quotient rule says, so Nick, we are doing a review. If you can copy these down with us, maybe take a screenshot of number 1 and 2. And then we're going to move on to number 3. So number 3 requires that we use the quotient rule. So it's going to be the bottom times the derivative of the top. Now you should put that top derivative in parentheses. So the derivative of the top is 8x plus 3. Now it's very important that you do bottom times the derivative of the top. The product rule, the order doesn't matter so much. The quotient rule, you have to do it in that order. So it's bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Now, again, when you're taking the test on Wednesday, that's all I need to see. So that's as far as you need to go, okay? So let's go over it one more time. So it's the bottom times the derivative of the top. So the derivative of this is just 8x plus 3. Minus, it's always minus for the quotient rule, the top times the derivative of the bottom, all over the bottom squared. I forgot to write my square. Any questions about the quotient rule for number 3? Okay, let's move on to number 4. So for number 4, anytime you have a derivative that you're trying to take and you see a square root, a rewrite that you should do right off the bat is whatever is in your square root, take to the 1/2 power. Okay, so that's really important that you see square root and that you get yourself a 1/2 power. So now it's time to take the derivative. So that rewrite doesn't count. You got to take the derivative. Can anybody tell me what rule we're going to be stuck using for number 4?
Chain.
Yep, you got to use the chain rule. Now, how do you know when you use the chain rule? Well, the chain rule is when something is stuck inside of something and there's no way to manipulate or change it and bring it out of that thing. So if it's stuck inside of a square root, if it's stuck inside of a trig function, if it's stuck inside of something. And so what does the chain rule say? Well, the chain rule says that we use the rule that goes with that outer thing. So what rule is that? Well, that's a power rule. The power is going to drop down in front. You're going to leave the stuff alone, and the power is going to go down by 1. So that's the first thing you do. So the 1/2 drops down in front. Leave the stuff alone. Do the power rule just like before. But now here's the difference. We have to multiply by the derivative of the stuff inside. And so in parentheses, write out the derivative of the stuff that was stuck. Well, the stuff that's stuck is this 3x squared plus sine of x. So its derivative is 6x plus the cosine of x. And then you're done. Any questions about number 4? Let's keep going and talk about 5. Can anybody tell me, there are 2 rules we have to use for number 5. Can anybody tell me what they think the rules are we're going to use for number 5?
Chain and product.
Yes, that's good that you see that, because that's really important that we see there's a product there. But then as we do the derivatives, we have something stuck inside. So we're going to have to do a mixture of the chain rule and the product rule. So let's do the derivative here. So this is going to be my first. This will be my second. So it's going to be the first, write it down, times the derivative of the second. Now, how do we do the derivative of that? Well, it's very much like number 4. The 5 drops down in front. The stuff stays there. Power goes down by 1. But we have to multiply by the derivative of the stuff inside. So the derivative of 2x minus 3 is where the 2 comes from. Now we're going to add. So it was the first times the derivative of the second plus the second. So write that down. Times the derivative of the first. So that's a chain rule again. So the 4 is going to drop down in front. The power is going to become a 3. And then we're going to multiply by the derivative of the stuff inside. Now that's just a 1. You don't have to really write it. If you want to, feel free to. Anybody have any questions about number 5? Let's move on to number 6. 6, first, I hope you recognize based on what we've done earlier that this is a chain rule because this is stuck inside. What are we going to have to use on that fraction? What rule do we have to use when we do the derivative of the stuff inside? So let's go ahead and do its derivative. The power rule says we drop the power down in front, leave the stuff alone, power goes down by 1. But then we have to multiply by the derivative of the stuff inside. Now the stuff inside is a fraction. Fractions should use, that have x's in them, should use the quotient rule most of the time. And so let's go ahead and do that. So it's going to be the bottom, use parentheses, times the derivative of the top, minus the top, use parentheses, times the derivative of the bottom, all over the bottom squared. And we technically should even surround that in some kind of bracket or big parenthesis or something. Any questions on number 6? Okay, let's go to number 7. So, when I first look at something that contains a square root, first thing I like to do is rewrite that something to the 1/2 power. Okay, so that will kind of help you recognize that we have to use a power rule. But there's a chain rule here, and there's also a product. And there's a chain here that's going to happen. So we'll take those one step at a time. Okay, so let's do our derivative. So to start off, we always use the power rule because there's a power on that. So we're going to drop the power. Power's going to go down by 1. Okay, so drop the power, leave the stuff. Power goes down by 1. Okay. Now, we have to take the derivative inside. So like if these didn't exist and I said take that derivative, if those weren't there, that's product rule. So the derivative of the inside requires the product rule, which is the first times the derivative of the second plus the second times the derivative of the first. Put that in parentheses. So the first is 2x times the derivative of a cosine of 3x requires us to do two things. That's going to be a negative sign of the stuff inside times the derivative of the stuff inside. Okay, so it does require a little bit of work. Here, let's take that out just yet. Okay. Now, it's going to be plus the second times the derivative of the first. 2x derivative is just 2. And so that's your answer. Don't worry about trying to simplify it. Okay, let's go over that one more time. So the 1/2 dropped down in front. The power went down by 1. Leave the stuff there. And now this is the derivative of the stuff. So we're going to do first times the derivative of the second plus the second times the derivative of the first. Just remember, if there is something inside of a cosine, we have to use the chain rule. So it is the normal derivative of a cosine is negative sine times the derivative of the inside stuff. So if you have stuff in there besides an x, you got to do a derivative. Okay? Any questions about 7? Okay, let's look at 8. Now 8 has a few steps to it. The first part is to find y prime. The second part is to find the slope at the point 21. And the third part is to find the equation of the line at the point 21. Okay. So let's talk about the first step. On the test, this is what I need. So you don't have to do it beyond that first derivative. You don't have to do any rearranging for me. Let me show you what I want. Okay, so you see how the x's and y's are all bunched together. This means that's implicit differentiation, which I think is maybe less than 2/6. Okay, so this requires that we put those y primes on every time we take a derivative of a y. It's also going to require that we put a dot between these two to remember we have to use the product rule on that piece. Anytime the x's and y's are multiplied, that's a product. You've got to do the product rule. So this is all I need to see for y prime. Okay, so the derivative of x squared is 2x. The derivative of this, you are going to use the product rule. So this is my first, this is my second. So it's going to be the first times the derivative of the second. The derivative of y is y prime. I don't really know what it is. Plus the second times the derivative of the first. So the second times the derivative of the first. That's why I just got a 4 there. And then the derivative of y squared is 2y, y prime. So we took a derivative of a y, you always tack on a y prime. And then the derivative of a number, a constant, is 0. That's what you have to do. You don't have to rearrange it, okay? Sometimes you do, but in this case, that's all I need to see, that derivative, okay? Now, part B says to find the slope at the point 21. Well, the slope is y prime. So we actually physically have to plug in 2 and 1 for the x's and y's. Now 2 is x, 1 is y. So every x we see, make the number 2. Every y, not y prime, but every y we see, you make 1. And so 2 times 2 is 4. 4 times 2 is 8, y prime. Y times 4, y is 1. 1 times 4 is 4. 2 times 1 times y prime is 2y prime equals 0. Now you do have to solve for y prime here. Okay, so I need to know a number. I need the slope. So if we add the numbers together, we get 8 plus 10y prime equals 0. 10y prime equals negative 8. Y prime equals negative 8 over 10, or negative 4/5. Anyone have any questions about part B? So this is our slope. Negative 4/5. Now let's jump to part C. So part C, remember, is y minus y1 equals m times x minus x1. So what are we putting in? Well, our x1 is 2. Our y1 is 1. Our slope is 4/5, negative 4/5. So let's plug that in. So this is going to be y minus 1 equals negative 4/5 times x minus 2. You don't have to go any further. I know you can do the algebra to get yourself to the next spot. So there you go. Okay. So I know there's one like this on the test. I've given you something that you need to use implicit. I want you to find y prime. Just do the derivative and stop. For part B, you're going to plug that point in. That's my slope. Show me all of that, all the way to the point where you actually solve for the slope. And then part C, find the equation of the tangent line. You're always going to use that y minus y1 equals m times x minus x1. Just set it up and stop. Any questions about number 8? We're going to do one last problem And I think you have a good review for your test. Okay, number 9. It says find the volume of a cube is increasing at 10 cubic centimeters per minute. How fast is the surface area increasing when the side edge length is 30 centimeters? Well, I'm going to first remember it's dreads. So the first thing I want to do is draw a picture. Does it have to be an amazing picture? No. We just need some place to put our information. Okay? So I know if I call the side length x, this is x, and this is x, because it's a cube. So the volume is x cubed. Now, they told us that dv dt is 10, okay? And then they said, how fast is the surface area increasing? So we want ds dt, I'll call S surface area. And let's think about what the surface area of a cube really is. So each face of a cube, of a die, each face of a cube or a dice is x squared. There's 6 of them. So the surface area of a cube is 6x squared. Because there's 6 sides, x squared is our area of one of the faces of the cube. Well, we don't know dx dt. We do know that x is 30. Let's write that down. So first, this one's kind of an interesting one. Okay, so we drew the picture. We wrote down all the rates we're looking for and everything else. We have the equations we need. Now we're going to differentiate. So where do you start with this one? Well, let's start right here. Okay. So if we took the derivative of that, we get dv dt equals 3x squared dx dt. Okay? So the only missing thing we have dv dt is 10. We have x is 30. The only thing missing in that equation is dx dt. And so we know that 10 equals 3 times 30 squared times x dt. Now let's do some math here. 30 squared is 900. 3 times 900 is 2700. So dx dt is 10 over 2700. Now let's leave that a fraction. That's 1 over 270. And that would be centimeters per, what's the time? Centimeters per minute. Okay? Now, we want to define ds dt. Remember, that's what we were looking for. So let's look at the equation for ds, for the surface area. So the surface area is 6x squared. Let's differentiate that. So ds dt equals 12x dx dt. So we have now an equation for what we want. And so ds dt can be found by just plugging that stuff in. So x is 30. dx dt we found is 1 over 270. So we know what ds dt is going to be. So that's going to be 12 times 30 times 1 over 270. Now let's do a little simplification. 30 goes into 270 9 times. So that's going to be 12 over 9. And then they are both divisible by 3. So that's going to be 4/3. And the units here are going to be square centimeters per minute. That was kind of an interesting dreads problem. We kind of had to do 2 things one at a time to find what we were looking for, the change in the surface area. Okay? Any questions about number 9? Okay, well, that's a decent review about what you're going to see on the test on Wednesday. I will post this video so you can look at it. And I would look over some of the problems from the review that I had assigned last week. Make sure you know your derivatives of your trig functions, the product rule, the quotient rule, the chain rule, and then you're going to be good to go. There's only one, no, there's two dreads problem. One, I set it all up for you. I've given you all the equations and the rates and everything. You just have to find what they ask. And one, draw the picture and do the whole thing. Now remember, you're going to be showing me work for every problem, and you're going to turn in a little picture of the problems, okay?